Alright, so we're just going to keep on working on some more of these permutations and combination questions. And at this point, it's kind of like cheating almost because she has it lined up in different columns and you clearly know you're doing permutations over here and you clearly know you're doing combinations on the other side. But it is good practice typing in your calculator, but I will like to see us do some questions together where it doesn't tell us exactly which permutation or combination that you're using. So let's work on the permutations first. In how many ways can 12 horses finish, win, place, and show? So we have a total of 12, and we want to know all the different ways that all 12 of them can finish, place, and show. Don't ask me why. I have no idea. But that's a permutation because order clearly matters because we're talking about winning, placing, all that kind of stuff. So obviously first place is different than 12th place. So we're going to do 12, math, permutation, and another 12. Hit enter. Oh my goodness. That's 479,001,600 different ways that 12 horses can place in a show, which is kind of cool actually when you think about it. If there are 5 finalists for Miss USA, how many ways can a winner and a runner-up be chosen? Okay, so this time we have 5 total girls, and order clearly matters because we're talking about, a pageant where you get first, second, third, whatever. And we want to know how many different ways a winner and a runner-up can be chosen. So we're not doing 5p5 in this case, we're only doing 5, and then we're only interested in the 2 of them, the winner and the runner-up. So let's see how many ways that can happen. 5, permutation 2, and then hit enter. And there's only 20 different ways that you can choose a winner and a runner-up, which makes sense because there's only 5 total girls. So like you can see over here, when you use permutation, you're always talking about like a contest or a race or winning something because order clearly matters. Combination over here, we're going to see a lot of things about committees and groups and teams, and that's going to change things. We're going to deal with combinations in that case. So 12 men and 6 women are on a board. Okay. How many committees of 3 are possible? And here's kind of like a trick that is good help for the Regents. Anytime the word committee is used in a question, you are always going to use combination. You don't even have to think about it. If you see the word committee or team or group, you use combination. But the C and the C, it just helps. Committee is combination. So we have a total of 21 people because 12 plus 9 gives us 21 total people. So how many committees of 3 are possible? So we have a group of 21 people, but we only want to pick 3 of them. So let's see how many that will give us. 21, math. We're going to do combination this time. 3, hit enter. 1,330 different ways that we can make a committee. How many committees of 2 men and 1 woman? Okay, well now we're getting a little bit more interesting. Now we actually kind of have to think about this just a little bit more. Whenever you see the word and in a problem, you need to think of multiplication. Because a lot of people, I'm going to explain this a little bit more, but we're going to have to do 2 different sets of combinations, okay? So how many committees of 2 men? Well, how many total men do we have? We have a total of 12 men. So 12, we're choosing 2 of them. And then we also we want 1 woman on this committee. Well, how many total women do we have? We have a total of 9 women. 9, and we're choosing 1 of them. And then most students got to this part and said, are we adding those 2 combinations or am I multiplying those 2 combinations? And a really good way to remember it is if you see and, you're multiplying. Alright, so I'm going to do in my calculator 12 choose 2. You could do this step by step if you want to, or you can do it all at once. 12 choose 2, and I'm going to multiply 66 by 9 choose 1. Hit enter, and apparently there's 594 different ways that you could choose a committee like that, which is kind of interesting. Part C, how many committees of all women can be made? How many committees of all women can be made? Well, that means we have a total of 9 women, and we're choosing... That really, oh, I was trying to think of how many people are on the committee, but I guess it's 3, because we had 3 right here, and then we had a 2 and a 1, so it's still 9 choose 3. And the reason why I start off with 9 is because we have 9 total women, and we're choosing 3 of them, so 9 choose 3. Hit enter, so that's a total of 84. And then what is the probability of all women? Now this question isn't really worded very well, I guess. But what it is actually asking is, out of all the total possible committees that we could possibly make, what is the probability that you end up with a committee of all women? So what I would do is, if it asks you a question like this, a probability of all women, go up to the very top. You see how this first question said, how many committees of just 3 people are there? It was just saying 3, so that was 21 choose 3, 1,330. That is the, the total number of possibilities that we have for a committee. So that's when, you don't really even care who it is. You're just doing 21. Oops. You're just going to do 21 choose 3. But if we're looking for probability you always do the part over the whole. Just like if you were doing the probability 7 over 10 becomes 70%. It's the same thing. If you're doing part over the whole, probability of all the women, well, that's going to be a smaller number. We actually just figured it out. But it's 9 choose 3. Out of the total number of possible committees that we could possibly make, which is no matter how many guys or how many girls, that was the first one we did, which is 21 choose 3. So that's what we're really asking, and we actually already have both of those numbers. This is 84, and that was 3,000 or 1,330. So to find the probability, you just divide those two numbers. 84 divided by 1,330, that is 0.0631, and if you want to look at that as a probability, then you move the decimal over 2 places, and that's about 6.31% chance that that would actually happen. Probability a lot of times is thought of in terms of percentages, or it's thought of in terms of numbers between 1 and 0. So that was a decimal between 1 and 0. So you could leave it like that, or you could figure out what the percentage is, either one. But that question was worded very weirdly, and I don't really like that much. Let's see if we can do some more questions. Apparently not. Okay, this is homework in your workbook, page 547. Let's see what this is. 547. Okay, that is homework number 113. So if I remember correctly, it's just a bunch of questions where you do the counting principle, where you multiply options together, or it's using permutations and combinations. You're definitely going to need your calculator to do this homework assignment. So it looks like a lot of questions, but I'm pretty sure that they're actually pretty easy questions. Alrighty. I actually also at this point want to stop page. Okay. I actually wanted to, good thing she put those here. I wanted to do a couple of different questions with you that you might see on the homework. This is page 547, number 2, and I guess Miss Tompkins typed it in there for us. So here we go. Hannah is ordering a sandwich from the snack bar. She has a choice of 4 breads, 6 meats, and 3 cheeses. How many different sandwiches could Hannah order if she ordered 1 meat and 1 cheese? Okay. And I'm sure it's supposed to say 1 bread in there too. So this is a counting principle question. We have a bunch of different options to make. So we have 4 different options of bread, 6 different options of meats, and 3 different options of cheeses. So all you have to do is multiply those together. 4 times 6 times 3 is 72. 72 different options. That was a pretty easy question to do. Page 554, number 1. Okay, these questions are fun. And I hope that you think that they're fun too, but maybe not. But we're going to do one together. This is page 554, number 1. Okay. Given the integers 2, 4, 6, and 7, if each digit is only used once, how many different, and then we have a bunch of questions we have to answer. How many different 4-digit numbers can be formed? Okay. Well, let's think about this. We need a 4-digit number, so there's 4 different places right here. And we only have these 4 options. Okay, so if I take a look at the first digit of my number, how many different options of numbers do I have to put here? Well, I have 4 different total options, so that means I have 4 options for my first digit, which isn't too hard to think about. But it did say each digit is only used once. So no matter which one I chose, say I chose a 2, I can't use that 2 anymore. So how many different numbers do I have to put here? Well, now I'm only down to 3 left. And then say I use that one, I'm only down to 2 options. And then I'm only down to 1 option right there. And what you're going to do is multiply all of these numbers together, just like the counting principle questions. There's actually another way that we can write this out. 4 times 3 times 2 times 1 is actually the same thing as 4 factorial. And if you've never seen that before, that's what the exclamation symbol means. That's on your calculator. You type in a 4, and then you go to math, over to probability again, and it's right underneath the combination. That's option number 4. That exclamation point actually means factorial. And you hit enter, and apparently it's equal to 24. So 4 factorial is the exact same thing as if I took 4 times 3 times 2 times 1. And hit enter. See, it would be 24. So 4 factorial is just kind of like a shortcut so that you don't have to type in all of those numbers if you're doing something like this. Especially like 56 factorial, that's 56 times 54 times 53 times 52, all the way down to 1. Okay? So it just makes it a little bit easier to deal with. What about if we need a 4-digit odd number? Alright, so I have 4 different place values, and I'm going to multiply them all together. Okay, well, this one's a little bit different because this time we're dealing with just an odd number. So we have to think about what is it that makes a number odd? Well, clearly you know that the number 13 is odd, but the number 26 is not odd. That's even. So how are you telling the difference? You're telling the difference by taking a look at that last digit. If that last digit is even, then the whole thing is even. If that last digit is odd, then the whole thing is odd. So if I want to make an odd number, this last digit right here has to be an odd number itself. So take a look at all of our options. Well, this is even, that's even, that's even. So we only actually have one option that we can put right here, and that is a 7. So once we use that 7, it's taken off of the table. So now, come all the way back up to the beginning of the number. How many options do I have right here? I used my 7 up, so now I'm down to 3. Then I'm down to 2 options. Then I'm down to another 1 option. So this is definitely a different question. So this instead is 3 times 2 times 1, which is really just equal to 6. So there's only 6 odd 4-digit numbers that we can make. So these questions are kind of cool because it's kind of like a puzzle. This time, how many 4-digit even numbers can be formed? I'm going to let you work on that 1 second, and then I'll come right back.